All right, so today we're talking about Blenderbot. So Nick, take it away. Thanks.
All right, thanks everyone for coming. So today, following up from the last session, was sort of covering in general what conversational AI and chatbots look like today, sort of the limitations and opportunities. We're going to focus in on Blenderbot and Blenderbot 2. So Blenderbot came out, 1.0 came out last year. It's from Facebook. At that time, it was pretty close to state of the art. It was beating Google's sort of chatbot competitor, Mina. So it was doing better then, and then maybe a month ago, they released Blenderbot 2.0. And so they also released code for you to be able to interact with this, and you can download the parameters, and you can really kind of dig into this model. Unlike Google's chatbot, there's not even really a paper on it, and you certainly can't download the code or chat with it. So this is a good one because we can both kind of understand its components, what the new research directions are that are sort of most promising for chatbots and conversational AI. And lastly, we can actually play with it. So that's kind of fun. So in this, really, we're going to talk about Blenderbot 1.0 for a while, because Blenderbot 2 is really the same idea. It just has two small improvements on it. But these small improvements represent a pretty good deal of overall improvement. So we'll do Blenderbot 1, Blenderbot 2, and then lastly, I'll give you some code and an example conversation I had with Blenderbot. So you can, if you have a collab account, you will be able to run this model and talk to it yourself, and we'll look at that later. But qualitatively, it's the best chatbot I've talked with. So it's pretty interesting. If you've played with others in the past, even Blenderbot 1, it sort of represents a relatively smoother and more coherent kind of conversation. So it's fun to see. All right. A warning: this is a lot of notes here. Probably too much to cover in just the hour. So for some of these sections, because I want to get through all of this, and some of these sections are kind of better left for you to read on your own, I'm not going to go into great detail on every one. I think it's just better that way. If you have questions about, for example, there's a long section on decoding, which is what the Blenderbot authors view as one of their main contributions. If you're interested in that, I've given notes and some resources so you can look back at that, but I'm not going to try and spend a ton of time talking about decoding because we just wouldn't get to the Blenderbot 2 and the good stuff. So, all right, so let's jump in. The first sentence of Blenderbot 1 is, in this work, we provide recipes for building open domain chatbots that perform well in human evaluations. So Blenderbot is not really, and most of these kind of state-of-the-art dialogue systems are not so much showing off one particular model. It's about chatbot systems. So there's a lot of different components in there. And the other kind of sort of interesting part about that first sentence is that it's in human evaluations. So there's sort of a move towards automatic evaluation, which is maybe you measure the perplexity of your model, or you try to find some kind of gold label benchmark, but evaluating dialogue is very hard. So a lot of sort of the innovations and things that they bring are saying, let's have our evaluation be human-based, and let's do something really simple but really effective, like have a crowdsourced worker look at two different models and say, I'd rather talk to this one than that one. And that is, though a very kind of rough metric, it's really effective. So they're looking at human evaluations and just a kind of general domain and recipes for building good chatbots. All right. So the paper includes a lot of kind of different things they tinkered with, and different models, different decoding methods. So they kind of put at the front their main takeaways So takeaway number 1 is called blended skill task, and it's where the blender and Blenderbot comes from. So they say, we select tasks that make the model focus on personality and engagingness, knowledge, and empathy, achieving large gains by using the recently introduced blended skill talk dataset. Small models using BST can match or outperform larger models that do not. So we'll get to that in a second. And takeaway number 2 is decoder strategies. The bot's utterances are crucial to human judgments of quality. Too short in the responses are seen as dull or showing a lack of interest. Too long, and the bot appears to waffle and not listen. So constraining the minimum beam search length gives a crucial control of the dull versus spicy spectrum of responses. In addition, they have a lot of other tricks for what has kind of plagued text generation models. They have a few kind of tricks and recipes that can help get it more towards a coherent and engaging conversation.
I like how many sort of softer terms there are in here. Like, you know, it feels a lot less scientific, and there's things like engagingness and
yeah, exactly. And how does one measure engagingness? You know,
yeah.
So
Spicy,
it's
very technical term. Right?
yeah. But it's a good kind of. I think it's a smart move rather than trying to treat what is imprecise with some precise metric. We really deal with the imprecise with these qualitative metrics. And it is subjective, but if you have a big group of people who all have their subjective opinions, but they all agree, that's a good sign you're moving in the right direction.
Yeah. Are we gonna dive into the blended silk talk or no blended skill? That's funny.
Yeah.
Yeah.
Yeah. So this is kind of the header, and then we'll move into each one.
Cool.
Okay. So as I was saying, they try a lot of different models here. And if you have seen or you want to go look back at some of the presentations we've done on question answering, RAG is a good kind of segue into Blenderbot. Includes a lot of same ideas about having a retriever, a generator, and some way to basically generate text and augment it with knowledge. And so in Blenderbot, they try out a few different things. And so one approach is it's just a retriever model. So you have a set of dialogue responses, and you're really just asking, given some dialogue that you're having with a person, I have 20 responses, which is the best one. You also have a generator, which is a pure text generation, which is, again, you can look back at something like BART would be a good example of this, or T5, but it purely decodes text given some inputs. And Retrieve and Refine is sort of the one that, it's not unfair to say that both of the retriever and generator are kind of like baselines. The Retrieve and Refine with dialogue is a more kind of nuanced approach, and it's more of the contribution. But they need to prove that it's better than just a retriever or just a generator model. So Retrieve and Refine with dialogue, you take the output of the above retrieved model and you append it to the input of your dialogue history, and you feed this new input sequence to the generator. So essentially, it's like having a text generation model, but it's also conditioned on what the retriever model thinks would be a good response. So this kind of combination leads to better overall kind of responses and dialogue.
Hey, Nick, just a question on this. So, previously, so I might be wrong here, but just going from some of what I remember, the transformer modules were quite symmetric in the sense that, it was like 12 for the encoder and then 12 for the decoder. What are they, any thoughts on what they're able to achieve by this asymmetric sort of, different number of layers from the encoder and decoder?
Yeah, I'm not quite sure. This was, I believe, the 2 and 24, and I think Mina or their smaller version was something like 4 and 16. So I'm not quite sure what the idea is with having that big imbalance of, favoring decoders a great deal. It might just be that decoders specialize in text generation, so you want a ton of those layers, and maybe having a great number of encoder layers just hinders kind of speed. I don't quite think, or I don't quite know that it would impede performance. It would seem like having more encoder layers would help, but maybe for their purposes, this just happened to work better qualitatively, or it's a performance issue. I forget the exact parameters, but these layers are also incredibly wide. Mina is an enormous model. So maybe that, is another factor, but I'm not quite sure. It's a good question.
What does wide mean again?
The
size of embeddings?
Yeah, like very, very large embeddings. Okay. Right, so this is the retrieve and refine model. Retrieve and refine with external knowledge. It's kind of a last strategy. And you sort of insert a small component that says, okay, I'm having a dialogue with someone. Is what they're asking me, is it something that requires me to go get external knowledge? So if the person is saying, hey, how are you today? The kind of internal model can just handle that, this is expecting a chit chat response. But if the person says, hey, how are you, who is the 33rd president of the United States? This small little module is sort of there to say, this looks like we're going to need to go fetch some external knowledge. So this kind of model is sort of like a smaller, or I guess pre-RAG model, where it essentially has TF-IDF instead of DPR. But it's just some kind of retrieval method to look over Wikipedia articles and find the best candidate. And additionally, you sort of append that in addition to all of the other things to your input to the text generator. So you're basically just helping the text generator condition on dialogue history, what it thinks would be a good response given a set of pre-made responses, and finally your external knowledge if this requires external knowledge. So these are all kind of ways to just prime the text generation model to give you a better response.
So the refining step, does that mean taking like the past dialogue, like the previous exchanges, and adding that to the input, or is it like a two pass thing where it like generates output and then you feed it back and generate it again? Or something? Sounds like it's the submitting the old output, or
the refine is just sort of like augment or help, but the refine is the without any kind of if I say hey, how are you today, and you have a retriever model there, it can say a great response to this is just one of these pre-made answers that I have a big selection of. One of these, a good one would be, I'm fine, how are you? So if you add that to the generator, it can help do it on its own, but the generator might come up with that, or it might come up with something kind of weird. But basically giving it this, hey, this would be a good response, is sort of refining what it eventually generates on its own. Okay. The refinement is what the retriever pulled from a big set of predefined responses.
Gotcha. All right.
Okay. Small monster. Okay, I don't think this decoding is. We're jumping the gun here. Sorry about that. It's the next section. Okay. Data sets. So this is sort of those were the models that we'll be testing on, and data set and then decoding are sort of the main contributions that they view. And there's lots more about which loss function they use in the training regimen, but we're going to focus on data sets and decoding for Blenderbot 1. So how do you pre-train this model? You're going to need a lot of data. It's just like any large BERT model or transformer-like model. You need a lot of data, and you need some kind of simple pre-training task that can help you approximate, a good language model. And so in this case, we're really looking for something that's not common crawl. We're looking for something that's much more like dialogue. And there don't seem to be any enormous, pure kind of well-curated dialogue data sets. So what these dialogue models tend to do is use pushshift.io Reddit dataset. And so this is 1.5 billion examples of dialogue in Reddit threads. And there's, they have their own criteria for filtering this. And so you train, the pre-training task is to generate a comment conditioned on the full thread leading up to the comment. So as you can imagine, if you've seen a Reddit thread, it's a group discussion. It's pretty noisy. Some people aren't, responding sensibly. There's certainly toxicity in Reddit data sets, which we see on the other end. So it's really used due to its size, not its quality. And so we just really want to get a good approximation of language that has some element of conversation and dialogue. And the idea is you pre-train on this, and then more accurate but smaller two-person dialogue data sets are used to fine-tune the model and really further bring it into a place where it can have a coherent two-person dialogue. So fine-tuning.
Hey, so Nick, just a question on that, right? So if we are talking about a bot and you're having a two-person conversation and a Reddit thread is typically like a group conversation, why would that be a good candidate, right? And then the second question is, outside of, I'm guessing that there are copyright issues, which is why they couldn't use like a two-person film thing, or there's loads of these acts that potentially could be used. What are your thoughts on either of those?
I mean, I think you're right. I think it's not a good data set. I think it's just the best they have. So the biggest constraint here for a pre-training task is that it's very large. So I don't think group Reddit discussions are really ideal by anyone's standard, but it is kind of open source, public domain, very large. If there were some kind of publicly available data set that were just, dialogue interactions between two people, it's coherent, it's well moderated, I think that would far and away be the default thing that authors would want to train on. It simply doesn't exist, is what I'm gathering is the problem. Or, if it does exist, it's quite internal. So, Facebook certainly has access to lots and lots of two-person dialogues, but it's in Messenger, and I don't think if they did, I really don't know about this. If they did use that, they probably wouldn't publicize it. But yeah, ideally you would want this kind of large two-person public domain data set.
I like the film dialogue idea, but Reddit is like 1.5 billion examples. That's huge. So I wonder if you could even produce that much from film dialogue.
Yeah, and I mean the same could be said a little bit with like Common Crawl. It's not, it's not high quality, but there's a lot of it, and that there's a lot of it is really the biggest constraint.
Yeah.
So I mean, I'm also curious about if they were able to somehow aggregate or scrape together a 1.5 billion sized like dialogue history between two people that's pretty good and well curated. How much would our dialogue conversational AI models jump? I think it could be a great deal. So it'd be really interesting, and once again shows that a really big part of these big NLP projects is just having lots of good data.
And they don't share their post-processed data set.
They might. In the paper, they have their own kind of, they have like 10 criteria by which they filtered out certain dialogue. So, if one criteria was if the Reddit user is a known bot, another is, if it contains a certain amount of toxic language. So they tried to curate it down as much as they could. I'm not sure if they actually share that, but given that they're sharing the model, they might. So it's worth looking at. But yeah, just for scale comparison, all of these fine-tuning data sets, which are sort of used very often in creating these big NLP dialogue models. Conv AI2 has 140,000. Empathetic Dialogues has 50,000. Wizard of Wikipedia has 194,000. So we're not even really cracking 1 million examples with kind of good, high quality human dialogue that really showcases a lot of things like empathy and creativity and conversational flow. So it's really interesting to think about what would happen if we got a much bigger data set that could handle this. But I'm getting a little off topic here. All right. So fine-tuning. I believe in the beginning, the paper asks, they're searching for a goal of making more engaging, coherent, and empathetic dialogues. So to that end, they first train on these dialogue tasks and then make their own blended skill task, which essentially combines them. So we'll go through them. Conv AI2 is a training data set of 140,000 utterances involving paired crowd workers having a conversation. Each is given a role they play based on the sentences describing their persona, which were separately crowdsourced. So the idea is that you want to sort of artificially generate a lot of diversity even within these two-person dialogues. So if everyone, was from America and you say, what do you do for a job? And they say, I do Amazon Turk stuff. You wouldn't have a very diverse kind of set of dialogue. So each person is given a role to play. And this kind of is repeated through these different conversational AI data sets. But you want to sort of artificially generate some diversity. Empathetic dialogues, in this case, focuses on conversations grounded in an emotional situation. So one person plays a listener role, displaying empathy during the discussion. The other person, articulates some emotional situation that they're having. And once again, the goal is that you could give this to a conversational AI agent, and it would sort of inherit some of the empathetic responses that these two humans are naturally making. The Wizard of Wikipedia discusses a given topic in depth. The goal is to engage the partner and display expert knowledge. And once again, this is a kind of role play, and one person is given a Wikipedia article against which to answer these questions and try and engage the other one. So these are 3 separate data sets. The blended skill talk is sort of their innovation, and really they blend the 3 previous tasks to combine the skills from them seamlessly during dialogue. So they had some examples of this in the paper, just printed out for you to look at. And it really tries to be as full of a conversation as it can be, in one response ranging from empathy to sharing expert knowledge, to interesting discussions about one's life. So it's really trying to be the most kind of human, comprehensive dialogue data set that they can create.
So is it correct? I was starting to type a note there that the first 3 are pre-existing data sets, and then skill talk is there.
Yeah, exactly. They're sort of artificially saying, what if we have conversations that include all 3 of these facets of human conversation?
So that's quite interesting, because it sounds like the film option and better two-way conversations, they've kind of left that, so they don't seem to be so bothered about the initial bit, but it's really important for the fine-tuning bit, which is what they seem to have included here.
Yeah, I mean, I think it's important for the fine-tuning bit. It might be the case that some pre-training tasks use outside of Reddit, they might use film dialogue or kind of other external sources for dialogue history. Yeah, I have no idea if the film dialogue idea is used or would be good. It's sort of, one tries to approximate very normal human conversation because that's what the test and metric is. But I'm sure you could find some subset of films, like, maybe push aside the action films and the the noir films, and you have some set of films and their dialogue, which is sort of realistic, maybe modern day, romance or comedy or something like that. So it's a good idea.
I remember talking to a company years ago that was doing like audio search, and they were marketing it to companies for like customer support calls, being able to search those. And the guy quoted some insane number for like the amount of hours of customer support dialogue that are generated like every day or whatever. That'd be another interesting source maybe, but
yeah. And I think when these, if you're a company and you're trying to essentially augment or replace some of your call center allocation, you'll take these and you'll process these, and you'll sort of create a model that can either handle some of these and hand them off to a live customer representative. Yeah, so I think there's kind of a big opportunity there if you are trying to really focus on customer service. I think the goal on these is probably more, conversational fluidity. So if you were asking something trained on a lot of customer representative data, you would say, "Hey, how are you doing today?" They would say, "How are you?" Like, "I'm great. How are you doing? What can I help you with today? Is it checking your bank account?" So it's sort of,
right.
You might run into these walls. And so I think there's this, it's still early days of these kind of figuring out what curated data sets are really going to lead to the best outcomes. But yeah, I'm sure experimentation like with film or, a subset of customer representative calls is probably helpful.
Yeah. It could learn to get like really angry.
Oh, this is true. Just open my damn account. Like, yeah. I lost my password. Why can't you help me? This is horrible. Can I speak to your manager? Yeah.
Right, there you go. Just reply to everything.
Yeah, so we run into problems that I think maybe the authors of these data sets have run into this, and this is their sort of end solution. Yeah.
Yeah.
All right. So decoding is sort of one of the other aspects that they view as a big contribution here. And I don't think in any of our previous webinars, or maybe any of our previous tutorials, we've talked much about, at least in mine, Chris, you might have, in decoding. But it's sort of a natural question, and really the decoding strategy, given the same model, can vastly change what kind of responses the model generates. So you have this model that's predicting probabilities over a distribution of words. And so how do you go about generating a good response? It's not as though you can compute every full sentence response there is and then find the maximum. It's infeasible. There's sort of a, almost infinite number of kind of responses you could do. So really you have to find some kind of clever way to generate it piece by piece in a fashion that makes sense, that maybe looks forward a few branches, and, contains some variety. And as we'll see later, generating outputting the most likely sentence or response is not necessarily the best. And a lot of this is, I won't go into too many details here. There's a good Hugging Face blog here, and there's a good, I believe this is a NYU deep learning course, but they have a good page just on decoding methods. So if you're interested in this, you can look at it, but we'll just discuss a few briefly and sort of point to what the authors view as their main contribution. So the most kind of natural way one might first start doing this for any kind of autoregressive model is a greedy search, where you start with your beginning word, which in this case is the, and you find, given the first word, what is the most likely next word. And that's nice. It has the highest probability of 0.5. and so on and so on. So you come up with a nice woman, and this generates, not necessarily your highest probability response, but it's a good kind of approximation. But you can miss very high probability sequences, or even the highest probability total sequence if any single word in the sequence is low probability. So we'll see an example of that with the same kind of tree in beam search. So the idea of beam search is essentially to look ahead n steps at branches to see how your total sequence probability looks if you pursue that branch versus if you pursue the middle branch or the lower branch. So in this case, we saw in the previous, if you use greedy search, you get the nice woman. And nice has a higher probability than dog, and woman has a higher probability than the other option. So you get a sort of probability total for the sequence of 0.5 times 0.4. But if you go the dog has, you end up with a higher probability total sequence, just because even though dog was a lower probability option, has ends up being at 0.9. So you get a higher probability total sequence. Neither of these are obvious, but essentially the idea is very intuitive. You want to look ahead before you commit to any single branch and explore some further possibilities. But there are some sort of typical problems with beam search, and it's a very, very common technique, but there's some sort of problems, and this is what Blenderbot, the authors try and address, and they get kind of good results from. So these problems are really, they belong to every kind of text generation model. And so, one problem is it suffers from repetition.
Sorry, Nick, could you explain the look ahead bit, please? I didn't understand. So I get, how the nice woman is the good one, but I didn't understand how the dog has a better overall thing.
It would be because 0.9 here is higher than the woman 0.3. So 0.4 times 0.9 is 0.36, and 0.5 times 0.4 is 0.2. So it's, even though we had to go down a slightly less optimal branch, we end up with a very optimal final kind of sequence. And it's not really apples and oranges, because it's the probability of has given the probability of dog. So it's not quite apples and oranges, but I encourage you to look at these kind of these blog posts, and they have a great number of details and more illustrations to really help you grasp it.
Okay.
Beam search it's a good thing to learn. It shows up all over the place, so it's really worth your time if you're interested in this to look at beam search techniques and kind of what the main ideas are. So for text generation, and this is a big problem with dialogue agents, there are these kind of problems. So here, beam search can work very well in tasks where the length of desired generation is more or less predictable. But there's some problem where the desired output length can vary greatly for dialogue, for example. So if you know how long your response should be, you can kind of tell the model to keep going instead of generating an end of sequence token. And this will prevent things like, maybe I'm the dialogue agent, and I'm talking to a chatbot, and I, give it this long conversation, this long paragraph about my thoughts on, foreign politics, and its response is just 3 words and says, "Oh, sounds good. I don't know." So, if you can kind of understand that, oh, this long paragraph that the person has given the chatbot, sort of in natural conversation, it requires a long response, then that kind of information can help you input a kind of more coherent, sensible response rather than just, I don't know. So additionally, we'll come back to this, the Blenderbot authors have a kind of solution for this. suffers from repetition is just a big one. You might kind of get caught in a loop of your most probable next word is just or next 3 words is just the repeated previous 3 words. So you can just, this is very common in text generation. So you have to have some kind of way to address this. It's especially hard to control with n-gram or other penalties in story generation, since finding a good trade-off between forced and no repetition and repeating cycles of identical n-grams requires a lot of tuning. And this means if you enforce that you cannot repeat the same words, the same 2 words, you might just get very kind of loopy talk, because if you've already said I am earlier in your sequence, you're no longer allowed to say I am again. This would prevent you from, ever just repeating 2 words over and over again. But that's a very kind of useful sequence. So you would be penalizing the model from ever saying that again. And you sort of end up with very odd language. So it's, again, this kind of balance between having safe, high probable words that are boring or incoherent just because they repeat, versus having, a wider distribution of probabilities that's the model is picking from, but it can be quite loopy and weird and incoherent.
When you say loopy, do you mean like nonsensical, or like it's repeating itself?
Nonsensical in that it's sort of picking out far-fetched, low probable next words or next sequences in a dialogue response.
Gotcha.
And that's only because it's used previous ones, and so in order to not use those ones, it's always trying to get the next one.
This is one cause for it. The other much bigger cause is that you're doing some kind of sampling, or which we'll get to in a second. You're doing some kind of sampling or forcing the model to pick less probable options, because the most probable sentence is not how people talk. So high quality human language does not follow distribution of high probability next words. In other words, as humans, we want generated text to surprise us and not be boring, predictable. The authors show this by nicely plotting the probability a model would give to human text versus what beam search does. So as you can see, the blue is sort of the probability if you were applying the probability to human speech, and beam search is the orange at the top. So the beam search responses are very, very probable, but in fact, they're not how we talk. And these beam search responses, you could guess, are something like, I don't know, I am fine. All of these kind of very inoffensive, highly probable, low risk kind of things. But this is, this fails on engagingness, and it fails just in the way that people talk. People, introduce new words and new ideas all the time, and without introducing new words and new unexpected ideas, you don't really have conversation. So the sort of way to address this is a sort of big category of sampling, where essentially you are trying to avoid taking the highest probable word or the highest probable branch. And really, this is just a way to give your conversational AI more spiciness. So you're really just trying to, increase the chance that you say something that is maybe not totally wild, but not the most probable next word. So I won't go into details of what sampling is. I will talk a little bit about temperature, because this shows up in pretty much every dialogue agent I've tried out. They give you a parameter called temperature. And essentially, if you are looking at the model and it has a sequence of words preceding and it's looking for the next word, it creates a probability distribution using a softmax over all possible words, right? So the next, the next word might be the with a 0.8% probability, or a 0.8 probability. And then, the rest is sort of distributed out with a very long tail over all of the rest of your vocabulary. Temperature is something that basically changes the nature of the softmax, so that we can select for the low probability words under normal softmax to have higher probability relative. So if you, oops, well, we can fit it in here. You recall this is the normal softmax. And so the temperature adjusted softmax essentially just adds a variable here. And you can really think about it as essentially squishing the probability distribution. So there's a nice sort of visualization of what's going on here. And if you think the x-axis, in this case, if you think of them as words, you can see the effect the temperature has on the probability distribution, which is the y-axis of how these words are selected. So if you turn the temperature way up, then you're using essentially a normal softmax. Wait, hold on. Temperature is a parameter of the softmax functions that makes the distribution give even higher probability to the high probability words. Right, so if you have a low temperature, you're giving a higher probability to the high probability words, meaning that you're essentially just performing greedy search. The closer and closer you get to zero temperature, and temperature equals 1, then we're essentially using the normal softmax. So basically, it's a way to control the spiciness. So if you have it very low, then you're essentially getting very boring responses. If you have it at 1, then it's kind of it's giving you more unexpected sampling from the distribution of words.
So let's see. Yeah. So you can change the distribution, but the relative probabilities presumably remain the same.
Yeah.
So how? Yeah, it's. I guess it's when you look at these are like probabilities for a single word, I imagine, or characters. Even it looks like it's doing character generation.
This is discrete elements. This characters, yes. Yeah.
So that's maybe right, not the right output type for what we're actually talking about, but yeah. So if your model just always picks the most probable next word or character, then like the temperature wouldn't matter. So this would come into play more if you're doing the beam search thing and trying to find the highest probable overall sentence.
Mm-hmm. Yeah, there's something, I can go back and fix these notes. There's some, I'm missing some element here, but essentially the temperature is a hyperparameter or a variable you can adjust as you're talking to most of these models. And it essentially controls and I've seen spiciness used in many places, so the spiciness of the text that's generated. So I'll go back and sort of rewrite this.
Where temperature is more spicy, is that right? Or other way around?
Yeah, but I'm sort of confused because I thought the temperature was, and it's not what I have here. But increasing the temperature would actually raise the probability that under a normal softmax, this word way out on the long tail of the distribution has a very low probability. Temperature could raise those probabilities and lower the very high probable words, so that essentially you're kind of flattening out the distribution that might be very skewed towards high probable words. You sort of smooth out and flatten out the distribution so that suddenly a word that was under normal softmax very, very unlikely has a higher probability attached to it.
Yeah, so it seems like it's a modification that actually allows you to make the dialogue less spicy. Like if you just kind of leave the softmax as it is, that gives you the highest spiciness, and then being able to lower the temperature means you can like make it more boring.
Exactly, and this is what I think is why I've got something wrong here. But because it should enable you to actually flatten out the probability distribution rather than just being
like make it more uniform is what you're saying.
Yeah, as you said, very boring to normal softmax. It should also take us to very spicy. Yeah, so have to take another look at this. This was pre-coffee writing, so you'll have to forgive me.
Never do that.
I'm learning my lesson.
Recipe for disaster.
Yeah. All right. Oh boy. Yeah. Got not much time. We might not get to Blenderbot 2, but we can finish up, and I'll at least you'll have the notes for Blenderbot 2 and some code to run it. So I'll at least try and get through the rest of Blenderbot 1.
Yeah, we can always do another discussion too. If,
yeah, this is true. All right, so the Blenderbot specific decoding findings, and essentially we just needed to have some kind of overview of what decoding is doing in order to understand their kind of contributions and modifications. So their modifications directly address some of the most common problems with beam search and decoding of text generation models in general. So it can be unresponsive, it can be short, generic answers, you can have repetition, you can have dull responses. So modification 1 is requiring minimum or predictive length responses. So essentially, when you're looking at a text generation model and you're asking it to produce a sequence, it will produce words until eventually it produces an end of sequence token. And that's essentially saying, period, I'm done talking. So you can modify this by saying you're not allowed to produce that end of sequence token until you've reached a minimum of 5 tokens or 10 tokens or 20 tokens. So you can either fix that minimum length, or you can kind of create a predictive model that will sort of look at the dialogue history. And as in the previous example, if I have a long paragraph that I'm giving the conversational AI about foreign politics, this kind of little predictive model would say it's time for a long response, versus if I just say, hey, what's up? The predictive model would say you don't need a long response. The minimum will just be 5. So you can either sort of fix the minimum, or you can have a predictive kind of model look at your dialogue history. But this helps prevent short, unengaging responses. And if the minimum is too long, it prevents kind of weird meandering responses. But in general, both approaches yielded much better dialogue as gauged by human evaluators. So you'll get the paper, they just have a lot of sort of tables comparing all of these different modifications they're trying. And this was one of the things that really yielded good responses and much improved dialogue. So you can see that this very small modification, we're not retraining the entire model, we're not changing the fine-tuning tasks, we're using the same model, but just by slightly modifying this decoding strategy, we get a big bump in performance. So it's really another demonstration that the decoding of your given model, the really specifics of the decoding really affect greatly the conversations that this model can have. So it's not all about, training a giant model. It's about, really fine-tuning and figuring out the right decoding strategy. So preventing the model from repeating a sequence of words was sort of strategy 2. This tends to increase performance, though the results were not significant. So this happens a few times in Blenderbot and Blenderbot 2, and in general, these kind of papers. The authors sort of have a qualitative feel that it increases performance, but they don't have statistically significant results to back this up. And they do this kind of a lot. I'm not quite sure what to make of it, whether this is we just take their word for it or what. But, for the rest of the models that they test, they enact this kind of strategy. Finally, find the sweet spot of beam search length. So it appears there's a sweet spot of beam search size where a value of 10 is superior to 1 or 30. Beam search is basically how far ahead we're looking at our conditionally generated sequence. So do you want to look, 30 branches ahead or just one branch ahead? And once again, none of these results is significant, but they kind of qualitatively feel that this kind of middle size of 10 beam search is the best option. And this would change depending on your model. But the idea is really that you have to do a little bit of fine-tuning and experimenting to figure out what a good beam search size is. Okay, yeah, so we've just got a few minutes left. The notes will be up, and yeah, we might just do this in section 2. But I'll just briefly talk about Blenderbot 2. So the great news is once you understand Blenderbot 1, you understand a lot of Blenderbot 2. They're basically 2 main changes and a few kind of small component changes where they substitute one model with another that's slightly improved since last year. So the 2 main changes are internet search augmentation and memory augmentation over dialogue history. So these represent a pretty good improvement over Blenderbot 1, a 17% improvement in engagingness score, a 55% improvement in use of previous conversation sessions. I'll note this metric doesn't make much sense because Blenderbot 1 is not able to have it's not able to remember what you said in a previous conversation if you turn it off and turn it on again. That's sort of the innovation of Blenderbot 2. So I'm not sure about that metric. Blenderbot 2 reduces hallucinations, that is knowledge hallucinations, where you ask it, what state is Atlanta in, and it confidently says California. That is a kind of knowledge hallucination. It's a problem with dialogue agents. These are reduced from 9% to 3%, which, if you think about it, is still a lot of hallucinating. And it's factually consistent across the conversation 12% more often. So these are kind of incremental improvements, probably due somewhat to these 2 new innovations, but also the kind of architecture of Blenderbot 2.0 versus 1.0 is that they've just added a few improved components. Like, instead of using TF-IDF retriever to look over a knowledge base, we're instead using DPR. That's not an example relevant to this, but it's just a kind of slight improvement in the way we do something, but the function remains the same. So very briefly, there's more. Here's the diagram they provide in the blog post, but internet augmentation, just to speak to it, is essentially instead of retrieving against a knowledge base, like you have a bunch of Wikipedia articles offline, and you are asked a question about what state Atlanta is in a kind of offline setting, you would then use this dialogue to create a query that looks at all of your Wikipedia articles, and you hope that it would find the Atlanta article and say this is the most relevant, and would use some context from this article to condition the text generator. In this case, instead of using an offline database, they are using a search engine. So instead of sort of querying against this big face index and using nearest neighbor search, you're essentially generating a query to type into Google, in this case Bing, and you are pulling out the most relevant results from Bing. So it's sort of an online versus offline dataset knowledge. Performance improvements aren't that big, and they don't show up in the evaluation metrics. Nevertheless, once again, the authors prefer this method qualitatively, if only for the fact that you don't have to maintain and kind of invent all of these knowledge to have a very fast, performant knowledge base. You can just leverage the fact that search engines are very good at what they do and simply ask them. And the second big innovation for Blenderbot 2 is dialog memory. And essentially the idea is that multi-session is now a thing where you can talk to the dialogue agent. You talk to the Blenderbot 2.0, you turn it off and you come back later and you can say, what did we talk about last time? and it will have created some memory of what you've talked about last time. So over multiple sessions, it has some access to your previous dialogue history that it's stored, and it's using this to sort of prime future conversations. So it remembers things about itself. It's not going to hopefully contradict itself and say it lives in one place, and then 10 minutes later in the conversation it says it lives somewhere else. It improves consistency and memory about the person it's talking to. And briefly, the kind of approach they take is the most successful approach is to look at the dialogue history, and you're sort of just creating an offline text document containing information. And they use a summarization model to essentially take this dialogue history and they sort of condense it into facts. So if I have a long dialogue and I'm saying, oh, I work in AI and I do some some education, I've worked with financial compliance and all of this, it will kind of condense it into a few places, into a few smaller pieces of raw text. And then the next time this conversation comes up, it will use a retrieval model to try and find this and use it to prime the text generation. So it says, in the same way you would if you were retrieving knowledge, it will just retrieve knowledge about our past dialogue. And so those are the kind of two improvements that they've added to Blenderbot 2 and that they're touting as kind of the difference. Okay, so that's kind of a brief overview of Blenderbot 2. And here at the bottom, I've got just pulled out some of the specific architecture components they're using. There's a lot of little pieces. Once again, it's a system. It's not a pure model. So there's a lot of little pieces, and these are the components they use. And then I had tested this out a little bit. There's just a couple notes. It's very easy to run on a Colab notebook. You just install a few dependencies and you run this. And then you can get talking right away. Not right away. It takes a long time to load the models. But I've just got a few notes on what it can and can't do. And some observations, and here's a sample dialogue. So yeah, you can look at this and try it on your own. I encourage you. It's very easy. Just get a Colab notebook open and get going. But yeah, qualitatively, it's the best model I've talked to. It still has a lot of problems. It hallucinated knowledge. It's pretty dull, but it's sort of had the smoothest and most coherent conversation I've encountered in a while. So yeah, that's all. Yeah, so we might come back next week and give a little more attention to Blenderbot 2, or we'll see.
Oh, I was on mute. Yeah, sounds good. This is interesting.
Thanks.
Yeah, of course.
They gave it a favorite show, Breaking Bad. Do you think they kind of hard-coded that? Like the established response, or like?
It's an idea.
I think GPT-2 uses Breaking Bad. If you ask who are you, it replies with something from Breaking Bad. I'm the one who knocks. That's from one of the episodes.
Yeah. I am the danger.
Yes.
Yeah. It volunteers Breaking Bad as its favorite show. Said, I like the episode where they throw a pizza on the roof. Do you know what season or episode that is? I'm not sure, but I do know it's the first season. I don't know the show, but it turns out that's in the 3rd season. So it hallucinates a little knowledge. I ask it more questions about its favorite show. There's a lot of I am not sure, which is probably better than just hallucinating knowledge. But, I tried tested out in a few things. It knew who Giannis was. So it supposedly has some kind of more recent knowledge, but it didn't know who won the NBA championships. So it's really a mixed bag, but it's the best I've seen. And this is the smaller Blenderbot model. They have a 2 billion version. If you happen to have a setup that can handle that, you can try that out. This is the 400 million parameter model that they have open sourced for you to talk with.
So when you run this, it needs to run, locally. Like if you're running in Colab, it would be the Colab instance. But yeah, it's not like GPT-3 where you're talking to their server room or whatever.
No, yeah, you're talking to the model itself. And yeah, this was able to load on Google Colab. So.
And then how long does it take to come back with these responses? Is it pretty slow, or is it?
It's pretty quick, and it's pretty quick, and it's hitting a search query API. And I know this because, well, I don't quite know because it didn't give me enough information to deduce that. Like, I said, what was Biden's announcement on Afghanistan the other day, and it said, not sure. But if you ask it enough questions, eventually you're kind of, you're like rate limited. So I kept getting booted out of the conversation via like HTTPS requests.
Yeah, interesting.
So I think that you're hitting Bing too many times.
Right.
Yeah.
Cool. All right. Yeah, it looks like there was some answers about the temperature thing in the chat. I missed those earlier. Sorry, guys, but thank you for.
Oh, nice.
Thank you for.
Yeah, we'll have to clean up that section.
Yeah. Cool. Yeah, let's wrap it up there. It looks like it recorded successfully this time, so I'll send out the video and let you guys know what we're doing for next week.
Thanks, Nick and Chris. Appreciate your time.
Yeah, thanks for coming.
Yeah, I appreciate it. Good discussion.
All right, have a good one.
You too. Take care.
Bye, guys.